Surface roughness in manufacturing. Must know basics. When you line up metal parts with different surface roughness, you can literally see and feel the differences. But how do you actually communicate those surface roughness requirements to manufacturers? And how do you pick the perfect finish for your project? That's exactly what we're breaking down in this video. Let's start with the basics. What exactly is surface roughness? Surface roughness refers to the texture or irregularities on the surface of a material after it has been processed or manufactured. These variations can result from the manufacturing process, like machining, grinding, or casting, and can impact a material's performance, such as friction, wear resistance, and how it interacts with other components. But how do we actually measure surface roughness? Well, there are two main ways to do it: contact methods and non-contact methods. The contact method uses a stylus that moves across the surface to record the tiny variations in height. This method provides highly accurate measurements, but isn't ideal for delicate materials since the stylus physically touches the surface. On the other hand, non-contact methods like laser scanning and optical interferometry use light to analyze the surface without any physical contact. These are great for measuring soft materials or intricate details without causing damage. Now that we know how to measure surface roughness, let's explore the roughness parameters. These are like a language that helps us understand the texture of a surface in a precise way. Roughness average, RA, is the most common roughness parameter. It represents the average height of surface irregularities over a given distance. The lower the RA value, the smoother the surface. For example, a mirror-polished part might have a RI of just 0.5 micrometers, while a standard machine surface could be around 3.2 micrometers. In manufacturing, surface roughness charts are super important. They show different RI values with real-life examples. It is a super handy tool for manufacturers to measure and hit the right surface finish standards. But keep in mind that not all manufacturing processes can achieve a mirror finish like RA 0.05. In fact, each method has its own roughness personality. Milling gives you a typical surface roughness of 0.8 to 3.2 micrometer, solid for general machining. Turning tends to leave more visible tool marks, with a roughness range of 1.6 to 3.2 micrometers. Grinding can deliver a much finer finish, bringing roughness down to 0.2 micrometers. EDM, electrical discharge machining, usually results in a roughness between 1.6 to 6.3 micrometers. Laser cutting has a higher roughness, typically ranging from 6.3 to 12.5 micrometers. And 3D printing, it's the wild card. Roughness can swing anywhere from 3.2 to 25 micrometers, depending on the tech and material. What's more, even within the same manufacturing process, surface roughness can vary depending on several factors. The type of cutting tool makes a big difference. A sharp, well-maintained tool will give you a smoother finish, while a worn-out tool can leave a rough, uneven surface. Cutting parameters like speed and feed rate also play a role. Higher cutting speeds usually result in a finer finish, while slower speeds can leave more visible tool marks. And the material itself. Softer materials like aluminum are easier to machine smoothly, while harder materials like stainless steel often end up with a rougher surface after machining. So, it's all about finding the perfect balance. Smoother surfaces can boost performance in many ways, like reducing friction and wear, but they often come with a higher price tag. For example, if you're designing precision bearings or aerospace components, a fine finish is necessary to reduce friction and wear. Medical implants also require ultra-smooth surfaces for hygiene and safety. But for general industrial parts, a standard machined finish is often good enough and more cost-effective. Surface roughness is a big deal in manufacturing. It impacts performance, durability, cost, and even appearance. If you need help with surface roughness for your project, we have professional support. And if you found this video helpful, be sure to like, subscribe, and stay tuned for more manufacturing insights.